Hello friends. So here in this video we are going to study regarding the mixing of two air streams. Basically in case of air conditioning system or the working of ACs, in that video we have seen that the air from the room will be taken back and the um, fresh air from the atmosphere will be mixed with this particular return air. Okay, so obviously when the return air from the room which is taken back and the fresh air, both these airs are getting mixed, the state of the air after mixing will be the different state, and that mixed air will be then passed over the cooling coil. Okay, generally that is what is happening in the AC units. Okay, so we will see how to study the state number 3 mixed state over here, how to get the mixed state over here. So here I am showing one is nothing but the outside air, okay, which is taken from the atmosphere or the fresh air. This is the air which is taken from the room basically, which is at the state number 2. And when I mix point number 1 and point number 2, that is outside air and return air, obviously the mixed state will be totally different than the point number 1 and point number 2, and that will be nothing but the state number 3, which is nothing known to be as the mixed air. Okay, so with respect to this particular point number 1, assume that the mass of air is m1, enthalpy of air is h1, and the specific humidity is w1. Whereas for return air the mass is m2, enthalpy is H2, and the specific humidity is W2. Whereas for mixed air it will be, let's say, M3, totally different state than the 1 and 2, H3 and W3. Fine. So now with respect to this particular diagram, I can write one equation for mass M3, which will be obviously the mass of air outside air M1 and the mass of return air M2. Okay, so this is I can call as the equation number 1. Now for energy balance, the outlet energy will be equal to the inlet energy. So here outlet is 3, whereas inlet is point number 1 and point number 2. So for the energy balance, I can write the equation as that M3 into H3. Now here the energy is nothing but M into H, where H is nothing but M into Cp into T. Okay, so Cpt is nothing but the enthalpy, which is nothing but the energy Q. Correct. So M3H3, which will be equal to obviously M1H1 plus M2H2. I'll replace this M3 from the equation number 1. So it will be M1 plus M2 into H3, which will be equal to M1H1 plus M2H2. I'll simplify this. M1H3 plus M2H3 is equal to M1H1 plus M2H2. I'll take M1 terms on this particular left hand side. Let's say M1H3 minus M1H1, which is equal to M2H2 minus M2H3. Fine. I'll take the M1 common over here, H3 minus H1, which is equal to, I'll take M2 common over here, H2 minus H3. So the ratio of M1 by M2 outside air to the return air will be equal to H2 minus H3 divided by H3 minus H1. Now obviously in case of numericals, I will be knowing the M1, I will be knowing the M2, I will be knowing the conditions of inlet air H1 and the room design condition H2, so that easily I can get the H3. Okay, we'll understand this with the psychrometric chart. Assume that the condition, outside air or the fresh air condition is 35 cdBT and let's say 55% RH. So somewhere here I'll be having the point number 1. Somewhere over here I'll be having the point number 1, and the inlet condition is, let's say, 25 cdBT and 50% RH. Okay, so somewhere over here. Okay, so this is nothing but the point number 2. Okay, so the final process will be from point number 1 to point number 2. So obviously when the air outside air 1 and 2 they are mixed, the mixing condition will be on the line 1 2 itself. It will be on the 1 2 itself. Okay, so where to get that particular mixed point? For that I can use that particular equation of the ratio m1 by M2 is equal to H3 minus H2 divided by H1 minus H3. Okay, that is the previous equation. H2 minus H3 divided by H3 minus H1. Okay, so this you can just reverse, because H2 value will be less than H3, H1 value will be less than H3. Okay, sorry, more higher than the H3. So it will be H3 minus H2 divided by H1 minus H3, that you can do over here. Okay, so this will be equal. Okay, so H3 minus H2 upon H1 minus H3. Okay, so now this particular point number 3 obviously it depends on the what value of M1 and M2 is. Okay, so the based on the percentage you can just put the values and then you can get what the value of H3. So suppose that I'm getting the H3 as 60. So with respect to 60, I'll just mark the line over here. I'll go perfectly parallel to the WPT line over here, and somewhere over here wherever it is intersecting to this particular line 1 2, I'll get the point number 3 over here. So this is my point number 3, which is nothing but the mixed condition. So when we solve the numerical based on this, we will see how to get the point number 3, that is a mixed point. Fine. So that's all about the mixing of two airstream. Thank you.